Nuke Studio is a product of the Foundry and can be purchased at thefoundry.uk for about $10,000. Green screens cover three processes: the chroma key, dspill, and color correction. We're going to start with the chroma key. Here we have our video footage with our green screen. And if we look here under the keyer, we can see all these different keyer nodes. This is why Nuke costs $10,000. It is the best green screen in the world. You can find videos how to use the rest of these at nukestation.com. We're going to use the key light because it is one of the most easy to use of all the green screen methods. I'm going to open up a checkerboard here to use for a background and connect the background pick whip to the checkerboard node, where I have my green screen footage plugged into the source. Now if we look at our key light node and we click on the color and then we control click on the green screen, it will pick our chroma key and remove the green screen. Right now you see that it's just black. If we control click shift drag, we can marquee select a greater area for a more diverse color. By clicking on the composite under the view, it shows us the background. If we notice under our screen gain, by raising the screen gain, it selects more colors. Also notice that the trees in the background are disappearing as well as the green screen. By moving the screen grain up and down, we can find a comfortable place to remove our chroma key. I'm using the up and down arrow to move the numbers in the screen gain. I'm going to press Ctrl Z to go back and select my color again and just choose a single color. If you notice though, it doesn't take out the ground under the green screen. We have to use a rotoscope to do that. So if we look under Draw and Roto Paint, we'll find the rotoscoping brush. We have our film plugged into the background, and under background 1, we're going to connect it to the checkerboard. Now we're going to select our rotoscoping brush, and by pressing Control and click dragging, we can change the size of our brush. Once we have the brush that we like, we're just going to paint out the areas that don't have a green screen on them. Now if we go over to the source and we change it to background 1, then you can see that we can see the background through each of our rotoscope brushes. You say, this works pretty good, man. All you have to do is just paint a little bit and the background's gone. But unfortunately, it's not that easy. We have to change the node for each of the brushes. And if we notice, when we change our timeline forward and back, the rotoscope only works for 1 frame. So this footage I have, it's about 500 frames right here. And I would have to go through and paint out individually each and every frame to remove the ground from the green screen footage. Skipping ahead, we're going to open up some different footage. And this footage has a tree in it. We want to put our animation behind the tree in this footage. So again, we're going to select our draw and the roto brush. This time we're going to select the rectangle Bezier. We're just going to draw a rectangle on top of the footage. And then under the node, I'm going to put a checkerboard in to use as my background. Now if we click on the source and select background 1, nothing happens. But if we go down to our output and we choose RGBA, then we can see our background because the roto brush creates an alpha matte for a previously made footage. We're just going to put another rectangle here to select the second side of our tree because we only want our tree to show up. We'll select background 1 for the alpha matte for our second roto brush as well, and go to the beginning of the footage. We're going to move the dots on our Bezier, and luckily they're keyframed, so all we have to do is move them for each frame, and it will remember what their position is for the frame. Not going to make you watch me do rotoscoping on every frame. So once you do it a few times, you'll learn that it takes forever. Now we're going to open up the same footage again, and we're going to switch it out for our checkerboard as the background. We're going to use a merge node to connect the footage. I'm going to delete my checkerboard because I don't need it anymore. Now if we go ahead a few frames, to see our tree, can't really tell the difference just looking at the footage. But if we connect our biker footage to it, which is what I have here, the biker footage that we used originally, finally I have my nodes set up right. You can see that our biker footage is behind the tree. The tree is rotoscoped out in front of the biker, giving it a sense of parallax. This is our second example of rotoscoping. And I'm going to do some cleanup, add a backdrop node and label it so I don't get a busy desktop. I'm going to call this Roto 2. Personally, I like Adobe's After Effects better than Nuke to do my rotoscoping. And if you've ever used Adobe Photoshop, then you're familiar with the magic wand tool. So we have our biker footage here in After Effects, and I'm splitting it up into 10 frame segments because if you try to rotoscope more than 10 frames, it just uses a lot of RAM and gets stuck. So first we select a roto brush, then we want to double click on the footage we want to rotoscope. I'm using a dual screen here, so your computer isn't supposed to look like this unless you have two monitors. And we use control click to resize our brush. And we're just going to drag our brush along, and the magic wand tool looks for a difference in the contrast between the colors. And so it will look and find the edges on the rotoscope selection. This works pretty good for doing your rough matte. if you're just trying to find the edges. But if you've ever used Photoshop, you know that we're going to invert our selection. I always use backwards. So we look at our bottom screen, we can see that we've removed the rotoscope and we've added the footage we want. And then we just go through and we use our magic wand roto brush to select the areas that we don't want. As I was saying, if you've ever used Photoshop's magic wand tool, you realize that it's pretty retarded. Here I'm alt clicking to select the area that I want to keep and regular clicking to select the area I want to remove. And it's just a time consuming process. And sometimes you have to draw your keep and remove lines right next to each other to get the program to understand what you want. But I find this form of rotoscoping to be faster than just painting it by hand. Especially since we look at our next step. Now that we have our selection made, we go down to our first screen and we push the next frame button, and it maintains the magic wand brush. We have a few problem areas here around the feet, so we have to smooth those out pretty much every frame. They get lost. But we're going to do this for 10 frames. And then once we have our 10 frames rotoscoped, I'm going to select my layer and go to Edit and Split Layer. I'm going to select the layer that I just worked on, the 10 frames. I'm going to go up to the second screen and press the Freeze button after I frame my selection. So I press Freeze and it will freeze the rotoscoping for those 10 frames so that they can't get messed up later on. Then I'm going to go to the next footage I'm working on and delete the roto brush from the previous footage and complete the process over, selecting the roto brush and double clicking on the footage I want to do the rotoscope on. Then we start the process over, selecting our basic areas, zooming into our problem areas and cleaning up our scene, going through 10 frames and freezing it. I found that this works faster than other ways. Next, we're going on to the second part of green screening, and that's the dspill process. Most people use a blue screen instead of a green screen because it produces less light. The green screen actually lights up your scene by adding more light. Now, if we look at the edge, we can see that the green screen is refracting onto the red coat. And if we look at our key light node, we actually have a dspill function on the key light node. So we're going to control click after we have our eyedropper selected and select the red color, and it removes some of the green. Also, we can use the alpha bias to perform this same function, control clicking to select our color, and it removes the green refraction. But if we notice, it has also made our helmet semi-transparent and given it a red hue. So we're going to press Ctrl Z to go back and verify that the dspill has the same effect on the generic dspill marker here. In fact, it does. It doesn't make the film as transparent, but it still gives it a red hue. So I'm going to press Ctrl Z to go back and show you how to use this expression that I found on YouTube. So we're going to press 1 to move our viewer pick whip over and double click our expression to open it up in the properties window. And the expression is just some Python code that's written out longhand. If we go up to color under math, at the very bottom we'll find expression. We can open up a new expression node. Then we're going to write out our expression longhand in the second channel. And it is G is greater than R plus B divided by 2 question mark times R plus B times 2 colon G. We want to make sure we have the green channel checked in our channel. And this also works for a blue screen. We can change the G to B and the B to G, and then it will remove the blue instead of the green. We want to check our blue channel instead of our red channel. I'm going to plug the expression into our source footage and press 1 to move the viewer pick whip, and I'm confused why it doesn't work. But once I debug it, I see that I didn't press shift to my plus sign. And now, if we adjust our mix, we see that it is removing 50% of the blue from our blue jeans, just using this simple longhand expression. So we're going to delete that and go back to the original. If we zoom in, we notice while it does remove a great deal of the green from the picture, it does in fact not do a very good dspill. There's still green refracting onto the edge of the jacket. So the last method I'm going to show you today is a gizmo. We're going to press 1 to move over to our gizmo. And this gizmo was downloaded off the internet from the Nukepedia.com under downloads gizmos. It's called Dspill Madness. And once you download it, you want to move it into the C drive users name .nuke folder. That's where you keep all your gizmos. So once you have it loaded into the correct folder, you want to right click, go to Other, All Plugins, go up to the top, click Update, and then go down to D, and you'll find Dspill Madness in your gizmos. So you open that up and collect it to the image, and we have it set up for green with an algorithm of average, and this one by far works better than the other two methods. We just move it around until the green has been removed from the jacket. You notice that we don't have transparency, and it's not leaving a red hue on our other colors. Last, we're going to talk about color correction. Color correction is about as diverse as fishing. People will tell you anything. Oh, you want to use a pink marshmallow and some power bait and a jointed lure. But anyway, I have some footage here I shot in my room because I didn't have the foresight to shoot it while I was at the park. And it's obviously not going to match up to the footage that we shot in the mountain. I'm using a yellow gel and a diffuse scrim to try to mimic the color of the sunlight, but it doesn't quite match exactly. Now here is a set of nodes that I have prepared previously. And if we move ahead into our scene, we can see that the colors just don't quite match up. It kind of looks orange. Everything else looks yellow. So we're going to find a good spot. You'll also notice that the frame looks very clean. What you want to do is take your camcorder and shoot a white card and record your clean plate, and then you can use that to put the blur on your image, because you can see my image is very clear and the rest of my footage is very blurry. So in a perfect world, you'd have a camera clean plate to blur your image. But since I don't, we're going to synthesize it using a blur and a defocus node. I have a really hard time navigating the timeline in Nuke, but if you middle mouse drag, you can select the area of the timeline that you want to frame. By pressing play, you can cache your footage, and that will allow you to scrub through it very quickly without waiting for it to load. So with the blur and the defocus node, the footage almost matches the footage that was filmed up on the mountain. Now if we go to time and we add a time offset, you'll notice our animation is not in here. So we're going to set our time offset for about 150 frames or something. And then we'll make our playback cache. I'm going to debug it, and I find that 250 is the correct number. So if we scrub through our playback cache, we can see that we now have our animation in our offset reel that matches up with our video. I'm going to press D to disable our defocus and blur nodes, and we're going to go on to actually adjusting the color. And the two easiest ways to do that are by using a grade node and a color correct node. If we open up our grade node, we can see that it has a bunch of sliders that allow us to adjust our black and white points. They don't really look very interesting right now, but I'll show you how to use them in a moment. With these 8 sliders, you can correct pretty much all the problems that you have in your color. Now, if we open up our color correct node, this allows us to use the HSV, things like saturation, contrast, and gamma. And it's also split up in between the 3 midtones, shadows, midtones, and highlights. And so you have the same controls for all 3 of your midtones plus your master. You can also open up the color wheel and you can add color tone to your mixture. Here I'm changing it to kind of a yellow orangish color. Or you can just adjust it by its RGB values. So here we're going to go over, we have a blank set. We just have the image of the motorcycle and we have the image of the background. And we're going to use those to explain how to do your workflow. First, we're adding our time offset. We're going to add a transform node so we can see our motorcycle guy a little bit better. We're going to scale him up and move him over into the scene just a little bit more. Then we're going to add our blur node and our defocus node. And I'm going to do some cleanup. I'm going to move everything over to this little area so we don't get confused. Pressing F to frame it. And then we want to adjust our defocus. And pretty much the defocus and the blur are about the same thing. They're a little bit different. I think one of them has like 5 stars and one of them has 6 stars, but they do pretty much the same thing. And by using a combination of both of them, you can pretty much imitate just about any kind of camera imperfection. Next, we're going to Control C to copy our selection, then Control V to paste it so we have a reference to compare it to. I'm going to press 2 to set up our second reference, and then by pressing 1 and 2, you can switch in between them. I'm going to clean up the first one by adding a backdrop node, and then we're going to add a color grade node to it. So by clicking on the color of our black point, we want to right click on the darkest point on our motorcycle guy. Then by clicking on the white point, we want to click on the whitest part of the motorcycle guy. Then we want to click on the black part of our lift, and we want to find the darkest color in our background scene. And then by clicking on the white of the gain, we want to right click on the lightest color of our background scene. And then if we compare our two, you can see that the difference is instantly noticeable. Just with those 3 short clicks, we have adjusted our footage almost seamlessly into our background scene. Like I said, the grade node is a very powerful node. Next, we want to click up top here and go down to our exposure clip warnings. And we don't really see anything right away. My mouse started screwing up right here. I'm going to delete this posterize. We're going to add our grade node into the merge so we can describe our clipping node. Now, if we move our white point, you can see that it starts clipping when it goes below white. That would be perfect white. So we're going to use our up arrow until we're right at perfect white in our scene. This will bring out our colors and make our whole video just pop with contrast. Now, if we turn on our white clamp and we move to our black slider, we can see that our black is clamping out at perfect black. So we want to move up our slider until we can find perfect black. And this also will really bring out the colors and the contrast in our scene. And it might not be a whole lot, but it's a lot better than it was to begin with. So we want to bring it all the way down until our black just starts clamping. The third kind of color we have is match grade. As you can see, these 2 footages are completely different. One of them is very blue, the other one is very green. So we're going to go to color, we're going to open up our match grade node, we're going to put our target on the color that we want to move, and our source on the color we want to go to. So we'll move our task to 2 variables. We're going to set a source and a target frame at 150. And another one at 200. Luckily, these 2 footages have the exact same frame range, so they're not offset. But using 2 reference frames helps if your footages are not offset. Then we're going to click Analyze, and immediately you can see that there's a large difference in the formerly blue film. It has what's described as a LUT, and we can save that LUT at the very bottom of the node. And that's pretty much all there is to know about green screen. So we're going to go on to camera tracking, which I used in my workflow here. We're going back to the very first part where I made the chroma key, and I've moved the checkerboard away from the background, and I've added this out M to the inverted alpha, so it includes our rotoscoping. So if we click out M to none, then we can see our rotoscoped alpha matte. So then we have our grade and our blur and our defocus, and then we have our final animated scene, which is what we're looking at in the video here. And we're going to rebuild this whole setup here for our animation. We're going to start out by importing some footage that I shot earlier at the bike park. And we get this second piece of footage. These 2 jumps look the same, but I assure you they are different piles of dirt. So we're going to take our second footage and start building our workflow node from our second footage from scratch. Well, to begin with, we want to create a merge node. We're going to merge in our green screened rotoscoped footage of our biker guy. And instantly we can see that something's not quite right. So if we press Shift X, then it will switch the values for our merge node, and it will put the biker guy on top of the footage. So we want the biker guy to come in the A and the B to be going out the bottom. So A is over B. Next, we can see that our biker guy is pointing the wrong direction. So we're going to go to Transform, and we're going to add a mirror node and get my pick whips lined up like they should be here, so it doesn't screw up this first right node that I made. we're going to select our mirror node and we're going to do a horizontal flop. That will put our biker guy pointing in the right direction. Next, we're going to add a regular transform node. And we want to move our center. Otherwise, it will rotate right around the handlebars. And we want it to rotate right around the foot pegs because that's where the center of gravity is on a motorcycle, down by your feet. So we're going to move our center values down with X and Y until we get it right around the feet using the up and down arrows to change the factors. Once we're satisfied that our center is in the right position, then we're going to reduce our scale to about 0.3. I think that's what I used on the last one. And once we have our scale and our center correct, then we're going to load up our timeline and find where our animation is on our biker guy. So we want to start about 150. Go to about 300. We want our biker guy to start at the bottom of the jump. So we're going to move him into position and start from frame 1. We're going to set a key on our translate, and we're also going to set an animation key on our rotate. So on frame 1, we want our biker guy to start at the bottom of the ramp. I'm going to zoom into our timeline and move forward to about where I think the animation is. I think the animation starts about 250. So if we move our guy up to the top of the jump, it automatically sets a key when we move our timeline there. Now, if we scroll forward, we see that the animation we're looking for doesn't happen until about frame 280. So we want to delete this key that we've just made on accident. We're going to set a second key for the correct spacing on 280. Then we want to move back to 250, where we set our exploratory key, and we're going to delete that by right-clicking and pushing delete key on our translate node, both for X and Y and then also for rotate. Otherwise, it will leave a keyframe there. We want the keyframe for 250 to be in a different place. So before we get carried away, we're going to adjust our two videos so that the animation lines up. So we're going to use our time offset of 150 so that our dirt pile video starts at frame 150. We just have a simple vertical zoom on our dirt pile footage. So once we've decided that we have our animation in the correct area, then we're going to set up our camera tracker. First, I'm going to disable the backdrop node for our biker guy. so that it doesn't bog down the processor while we're doing our camera tracking, because it's rather a time taking process. We go to 3D, and under 3D we'll find our camera tracker. We want to have our footage selected. We'll click the camera tracker, and then we want to press the track button under analysis. And like I said, this takes a couple minutes depending on how long your footage is, how crisp it is. Now we have our camera tracked tracks. So we want to go to the camera tracker drop-down menu and press solve under the properties, and that also takes a few minutes. And then once we have them solved, we want to look for the green ones that have a good track. We're going to right click to select a few of those, right click again and extract a user track, and that will be under the user track drop down menu on the properties tab. We want to scroll down to the bottom of our camera tracker properties and press export tracker. And then this will give us a user track, which is down here. We now have a track node. Now we can close our camera tracking properties. We want to press live link on our new track node so that it will be animated with our camera tracker information. Then we're going to make a second transform node and parent it under our first transform node. So our first transform node animates our biker, and our second transform node animates the camera movement. So we want to control click on the translate pick whip and move it up to the translate pick whip for the transform node that we've just created. We can close our camera tracker and then we won't see those dots anymore. So now we have only our transform 4 node. That is the camera tracking node that we've created. What this does is it creates the XYZ vector from the camera track and it transforms it into only an X and Y vector so that we can plug it into our footage. And if we play blast through our footage and we make this file cache, we can see that our camera tracker is moving along with the camera. Now I'm going to delete the animation by pressing no animation for both the X and Y vectors to show what it looks like if you don't track your camera. We're going to set the tracker back to 0 and then play blast through our footage again. And you'll see that our camera node does in fact not follow the camera animation. And this could cause a problem with your footage not lining up with your background unless they are correctly tracked towards the camera shake. So now that we have that set, we're going to open up the properties for our tracker 2 and control click the transform to the transform on the translate node, just like we did before. We're also going to close out our tracker node. If we don't have a simple animation, we can also connect the rotate, but there is no rotate in this footage. Then we're going to go back to work on our biker animation. So we're going to set our time offset to 0 to disable our background camera. And then we're going to press D to re-enable our biker backdrop node so we can see our biker again. And we're going to set up the animation on our biker transform node, which would be transform 3 as opposed to transform 4. Transform 4 moves the camera shake. Transform 3 moves our biker. So we're going to go back to frame 1, and we're going to line up our shot with our background footage so we can get a nice clean backplate where our biker guy follows the horizon of this dirt pile here. So about 255, we're going to put him at the apex of his jump. And we want to rotate him a little bit so it looks like he's taking off. I'm not going to make you sit here and watch me keyframe dozens of little keyframes on our biker guy. So we'll fast forward through this. I'm pretty much just doing the same thing, adjusting the translate and the rotate to make it look like he's driving over the dirt pile. We also disabled our transform because our parent transform was still moving our background animation. And we're going to turn our time offset back to 150 and turn our transform 4 node on. And now our biker guy should be lined up with our camera animation and our dirt pile. So we're going to clean this up, put it in a backdrop node, and name it Animate 2 since it is the second jump footage we have. And then we're going to click on our final merge that merges the two videos together and create a write node. Under File, we want to go to our destination folder, which in this case is Jump 2, and we want to properly name it. I'm going to call it jump2.3 hash marks because there are 3 numbers in our footage. We have 150 frames, so we need 1 hash mark for each frame. And we're going to make it a PNG because PNGs use an alphamat and they're still pretty small file sizes. Next, we're going to limit our range from 150 to 325. And if you're making a PNG, you probably want to make an RGB with an alphamat. Once you have everything set up, then we'll click the render button. Make sure that we have our frame range correct. I'm using custom instead of input, and we'll press OK. Then it pumps out 150 frames in a few minutes. And I'm going to take these over to Adobe to give them a quick play blast to see what they look like. So we'll go to File, Import File. We'll go to our destination folder, click the next one, make sure we have PNG sequence clicked. Open, drag it down to our working menu. We're going to hit the scrub button. We'll load it into our play cache, and then we can scrub through our timeline to make sure that our animation is correct and everything has loaded like we want it to.